In this tutorial, we will be discussing the overview of the different types of bonds. The Lewis theory generally predicts trends and properties, but does not give good numerical predictions for bond length and bond strength. It's a good first approximation of the bond angles in molecules, but usually cannot be used to get a good actual angle. Another issue with the bonding theory, the Lewis theory of bonding, is that it cannot write a single correct structure for some molecules. In fact, we talked about resonance before for, let's say, nitrate as an example, where it can go from one atom to the next. So it doesn't really give you a good blending of what's actually happening. It also does not predict the correct magnetic behavior of molecules. For instance, oxygen is considered to be paramagnetic. However, if you do the Lewis structure, it predicts it to be diamagnetic. So, what kind of bonds are actually forming? There's two different types of bonds. There's sigma, which looks like this in the Greek symbols, and then there's pi, which I'm sure you're aware of as far as the symbol is concerned. A sigma bond occurs when the electron orbitals of the atoms overlap within the plane. So in other words, this orbital and this orbital are coming together and they're overlapping over here. So electron orbitals of the atoms overlap within the plane of the bond's two atomic nuclei centers. To have a sigma bond, you have to have S and S overlapping, so one sphere with another sphere, or P to P from head to head. And this actually ends up lowering the energy. So energy of 0 is if there's no interaction whatever. And then as the atoms are getting closer together, they reach a minimum where that's actually the bond energy. So the energy actually decreased by coming together. But then if they get too close together, it goes right back up, and that's because the nucleus of each atom are interacting more. So this low point here is the optimal distance between these two atoms, and that is then considered the bond length. And this is where the overlap actually occurs. Then pi bonding occurs when electron orbitals of the atoms overlap sideways. So we have two p orbitals, and so we have an overlap here, and that's why you get this kind of weird shape here that looks almost like a circle or a square. This results in electron density being above and below the plane of the bond's two atomic nuclei centers. So pi bonding with the s and d orbitals are the only ones that really exist, not with the s. So compare and contrast sigma and pi bonds. The electron density between the two atoms are overlapping. The electron density within the plane of the bond. Whereas the pi bond, the electron density is above and below the plane of the bond. With sigma, can be formed with hybridized and unhybridized orbitals, where a pi bond can only be formed with unhybridized orbitals. Every bond contains a sigma component. Single bonds have only a sigma component, where pi bonds are for double and triple bonds, but they still have that sigma component in there. So a pi bond is the sigma and the pi interactions. And that's the overview of the two different types of bonding.